Question number 16. Okay. The diagram shows the dimensions of an elastic cord to project a stone. The tension in the cord is T. Okay. This is tension T. This is stone here. When the cord is pulled into the shape shown. Okay. It has been pulled. See how is the shape here? This is 16 centimeter. The equal tensions might be then this should be the midpoint. So this should be 8 centimeter here. That's what we can understand. 8 centimeter. What force does the elastic cord exert on the stone? What is the force acting on the stone? That's the question over here. So what we now do is that, see, let me consider this angle is T here, theta here. So this angle should also be theta. In that case, the component of T along this direction should be T cos theta, and along this direction should be T cos theta. And if I resolve this one upwards, this should be T sin theta, and downward should be T sin theta. So this and this force being equal and opposite, they will cancel. The total force acting on the stone should be 2T cos theta, right? So what I will do is I will just write 2T multiplied by, what is this value of cos theta? Cos theta here, if this is 6 and this is 8, this should be 10 here, right? 6 square plus 8 square is equal to 10 square, Pythagoras theorem. So therefore, cos theta should be adjacent. What is this adjacent? 6 centimeter divided by hypotenuse. What is hypotenuse? 10 centimeter. So it should be equal to 27 into 3 by 5, right? So centimeter goes away. So let us find out what is the 27 into 3 by 5. I can just write it like this. Okay, let me find out from here directly. So I can now write this as 2T. I'm sorry, not 27. This is 2T, right? 2T, not 27. I was thinking where this 2T comes into. 27 come into. So 2T, 3 into 2 is 60. This should be 6T by 5. Which is 6T by 5 is answer B. Okay.